Last lecture, we have used this formula. Suppose three lines are given to us. L1, A1x plus B1y plus C1 is equal to 0. L2, A2x plus B2y plus C2 is equal to 0. And L3, A3x plus B3y plus C3 is equal to 0. Then area of triangle formed by these three lines, we said plus or minus 1 upon 2 C1, C2, C3, determinant of A1, B1, C1, A2, B2, C2, and A3, B3, C3 bracket square. And we cross check that by using this formula, we got the answer, numerical answer correct, where C1, Ci is cofactor of small ci. Okay, so it is going to be interesting to prove this formula because it will not only give us this formula back, but also we will have some good practice of managing the algebra. Okay, I will give you the setup. I will give you the setup and you will prove it. Okay. Now, setup is as follows. Setup. There are more than one methods of doing this. I mean, if you start putting the values in this place and start expanding them, that might be the long method of doing it, but eventually you will get delta, area of triangle. Okay, but then we will try to do it efficiently, and therefore setup is important. I will call line L1 as cos theta x plus sin theta y minus p is equal to 0. I can always bring this line in this form. This is normal form. L2, and that is, I mean, I said that normal form is sometimes very useful when we derived that, and now this is the time where normal form is going to reduce a lot of calculations. Cos alpha x plus sin alpha y minus q is equal to 0, and L3 is cos beta x plus sin beta y minus pq r is equal to, right? So in this case, our determinant d is going to be equal to cos theta sin theta minus p, cos alpha sin alpha minus q, cos beta sin beta minus r. Correct? And then maybe we can have a very simplistic visualization of what we are doing, and therefore let us draw three lines, one like this, another like this, third like this, say for example. Okay, then O is the origin, you are dropping perpendicular. Okay, let us call this line L1, and therefore this angle is theta, and this length is p. Okay, it was a little closer to origin, but okay, I have managed it now. Then what is alpha? I draw perpendicular from origin. This is alpha, and this distance is q. Okay, and which line is L2? This line is L2, and this line is L3. Draw perpendicular. PQ, this distance is R, and this angle is beta. Okay, maybe you can call this point capital A, you can call this point capital B, you can call this point capital C. Then BC is small a, length of BC, length of CA is small b, length of AB is small c. Okay, and therefore if this is the setup, you should be able to prove this, because I have given you what do we mean by cofactor. So this is Ci is cofactor of Ci, means cofactor of this minus p, cofactor of minus q, and cofactor of minus r in this case. Okay, so I give you sufficient time. You have to show me, yes, proved, if you could prove it. Okay, let us first find out the cofactors. C1 is cos alpha, sin alpha, cos beta, sin beta. Sorry, which will be equal to cos alpha sin beta minus cos beta sin alpha, which is equal to sin beta minus alpha. Is that correct? Is this sin beta minus alpha? So
Yes.
refer to the diagram. This is beta and this is alpha. So we are talking about this angle from here to here. And sine of beta minus alpha, that is cyclic quadrilateral, therefore this is sine A. Similarly, we can say C2 is equal to sine B, C3 is equal to sine C, and therefore D is equal to, D is determinant, which we have learned yesterday how to expand it. Now we will expand using third column, and anyway those are cofactors, therefore minus sign if we take out, we get PC1 plus QC2 plus RC3. Is that right? Which is minus inside bracket P sin A plus Q sin B plus R sin C. Now, of course, we have to get rid of these signs and get into the sides eventually. Therefore, sine rule. Why sine rule? What does sine rule say? Sine rule will say A upon sine A is equal to B upon sine B is equal to C upon sine C is equal to 2R, that is diameter of ABC. Okay, so up to that point, all of us there understand what is happening. So sine A is A by D. Therefore, D is equal to minus PA by D plus QB by D plus RC by D. That is your that is what is your determinant. Now small a into P is area of the triangle OBC plus numerator, if you see, this is equal to minus 1 upon D times P into A plus Q into B plus R into C is delta, area of triangle ABC. Right? This implies D square. In our final formula, it is determinant square. Is this correct, or
2 delta?
2 delta? D square is equal to 4 delta square upon this. That is one part of the story. And the second part of the story is C1, C2, C3. What is C1? Okay, C1 into C2 into C3 is equal to sine A, sine B, sine C. Correct? Now sine A can be written as A by D, sine B can be written as B by D, and if we keep sine C as it is, then AB sine C is again 2 times delta. Half AB sine C is the area of triangle. So AB sine C is 2 delta and is D square, and therefore D upon 2 C1 C2 C3 is equal to D square is 4 delta square upon D square into 1 upon 2 into this one, 2 delta upon D square, which is equal to delta. Hence, rule. Very minimum calculations. And what is the trick? The trick is sine rule. I hope all of you have understood this. I will keep it on the board, one full view. You can note down whatever you want. And that is why this formula is important, because it not only checks your ability to visualize things, but ability to deal with different situations. Beta minus alpha was a direct angle here, but maybe when you take C2 and C3, you will get some other angle which is 2 pi minus that angle or something like that. But eventually, if you use trigonometry simplification, the answers will be C2 will be equal to sine beta and C3 will be equal to sine B, and C3 will be equal to sine C. So trigonometrically, they are going to be same. However, luckily here what we are getting is B minus alpha is visually the obtuse angle in my diagram, and therefore I can directly write it as 180 minus A, and sine 180 minus A is sine. In case of B and C, maybe you will have to consider the reflex angle, then take 360 minus that reflex angle, do some calculations, and eventually you will get C2 is equal to sine B and C3 is equal to sine C. And then all the calculations will go in place. Now, Will origin be always in the interior of the triangle? No. However, origin is in the interior. We have not considered anywhere here. We have not taken any sign, positive, negative, such that origin is supposed to be in the interior of triangle. We have not done that. We have done, this diagram is for explanation. Even if we don't draw this diagram, this proof will go through without any problem. We should do these kind of activities in the class. So, your line number 1 is 2x minus y plus 3 is equal to 0. Line number 2 is x plus y minus 2 is equal to 0. And line number 3 is minus x plus 3y minus 1 is equal to 0. I hope they are not concurrent. I hope they have some area. Find delta of triangle formed by L1, L2, L3. Okay, your time starts now. Okay. The way we have analyzed the parallelogram area formula in the end, after we got it, it was C1 minus C1 dash in the numerator, C2 minus C2 dash in the numerator, and if you observe what was the denominator, it was cofactor. Whatever we are considering as cofactor now, that was cofactor of only 2 lines were there. So if there were 3 lines, then it was a cofactor. But it is the same factor which is present in the denominator, which if it becomes 0, then the area of parallelogram would have been infinite. I mean, it's not a parallelogram. Now here also, if this problem statement was given to us, these are the 3 lines, find the formula for finding out area of triangle. So without doing any calculations, what we should have done, or what we can do it now, is number 1, area will have some value. This is very important, what I am saying right now. Area is going to have some value, some non-zero value, provided these lines are not concurrent. And we have developed the condition for concurrency of these lines. So if A1, B1, C1, A2, B2, C2, A3, B3, C3 is not equal to 0, then only the formula will come. If it is equal to 0, then of course delta is going to be 0. Okay. So we have to have this D in the numerator. So if I am trying to guess the formula, D must be there in the numerator. I don't know what power, etc., but D has to be in the numerator. What is the another extreme situation that we can consider? Maybe all 3 lines are parallel, or at least 2 of them are parallel. If 2 lines are parallel and intersected by the 3rd line, then real triangle is not formed, because these 2 guys will intersect each other at infinity, and therefore we'll have to consider that triangle and hence find out area of that triangle, which is going to be a very large number, big number. If really we want to find out, that means if first 2 lines are parallel, then A1 upon A2 is equal to B1 upon B2. That means A1 B2 minus A2 B1 is equal to 0. So, but A1 B2 minus A2 B1 is C3. So C3 must be there in the denominator. Maybe first line and 3rd line are parallel, therefore C2 must be there in the denominator. Second line and 3rd line are parallel, C1 must be there in the denominator. Okay, so your delta is going to be looking like the numerator is going to be function of this determinant, and denominator is going to be function of every cofactor, or maybe product of cofactor also we can guess at that time, because if any one of them is 0, everybody is 0. I mean, denominator is going to be 0, not acceptable. And maybe if all three lines are parallel, still denominator would become 0. And this f and this function would be different. So numerator is going to be function of d, denominator is going to be function of some c1, c2, c3. And then maybe what we can do is, we can say this is area, therefore let us say centimeter square or unit square. Unit square. If we really multiply, what is the unit of measure that we will get in the numerator? Can you figure out what will be the unit of measure of numerator? I mean, if we do this unit of measure balance, then I think we will get, it should be d square in the numerator, and c1, c2, c3 with some constant multiple in the denominator. हो गया, c1, c2, c3 is what is the degree of denominator? 2 4 6 असं काही करता येईल का? Maybe think about it, but I think guessing this d square also should be possible in the beginning. And then maybe if you have got this, then you take three simple lines whose area is known to you and put it in this and get the factor 1/2. That will complete your proof. Maybe check it for one more triplet of lines, 3 lines, and cross check whether you are getting the correct answer or not. I am not sure about this last step that I have told you about this balance. I will spend some time and find out, but I hope you have understood what should be in the numerator and what should be in the denominator. Without actually developing the formula, we should, and formula gives us exactly the same thing. That is what is mathematics. Okay, let me write down whatever we have done, and whatever we have not done, we have to finish by doing it. So 56%. 1. We know section formula. Or whatever. x1, y1, x2, y. mx2 plus nx1 upon m plus n. Or in terms of lambda also you can write. In terms of internal, external, I hope you will not get confused with that. So application of section formula 1, maybe I call this as I, this is 1, centroid. Okay, so maybe let me write down the master formula. X, red is bad, green, x is equal to weightage 1 times x1 plus weightage 2 times x2 plus weightage 3 times x3 plus weightage 1 plus weightage 2 plus weightage 3, and y is similar. Okay, so centroid, our weightage is We have done this in 9th standard. Second, incenter. If I want to find out incenter, W1, W2, W3. Do we know this? I think we have done. A, B, C. Third, excenter. Let us say opposite of A. What is W1, W2, W3? 4. Orthocenter. W1, W2, W3. And fifth, circumcenter. W1, W2, W3. Okay, fill in the blanks, complete this table, and maybe show me. Okay, the weightages are excenter. If it is opposite to A, then it is minus A, B, C. Opposite to B will be opposite of B. Both remaining will be positive. Opposite to C will be opposite of C here, and AB will be positive cyclically. Okay, orthocenter will have tan A, tan B, tan C, and circumcenter will have sine 2A, sine 2B, sine 2C. Okay, in center using pure section formula, we can do it. Maybe quickly I can show you. This is internal angle bisector. This is A, B, and C. Then this is small c, this is small b. Then point D. D is dividing BC in the ratio of C upon B. Therefore, this is AC by B plus C. And this is BC by B plus C. In center, again because this is angle bisector, in center I, this will divide segment DA in the ratio of AC upon B plus C S to C. That is A upon B plus C S to 1. So A upon B plus C times x1 plus 1 times x2. No, sorry. Everything is wrong because I have to first calculate what is D. D is in the ratio CS to B. Therefore, CX3 plus BX2 upon C plus B, that is D, and therefore I, X coordinate of I will be A upon B plus C times X1 plus 1 times this number. This is XD. CX3 plus BX2 upon B plus C and whole divided by A upon
Sir,
C plus 1. बोला.
सर BD upon DC C is to B पाहिजे ना?
BD upon DC C is to B पाहिजे. हो. C is to B घेतलंय मी, इथे चुकून हा A पाहिजे इथे. ठीक आहे. So if you simplify this, you will get ax1 plus bx2 plus cx3 upon a plus b plus c. Now, in case of excenter, that is external division, therefore you need to introduce this minus sign, which eventually will appear in the weightage. Okay, so if we want to do now orthocenter, then we need triangle, altitude, and then orthocenter H, A, B, C, D, E, and F, maybe. This is 90. So this is H. So first we need D, coordinates of D, then we need coordinates of H. So in what ratio D divides BS to C we need to find out. And after that, in what ratio H divides D's to A, that we need to find out. And if we use those lengths, which we anyway know in trigonometry, what is AH, what is HD, what is BD, what is DC, etc., then I think we should be able to get it. Can somebody dictate me quickly what is D? A is x1, y1, x2, y2, x3, y3. Then can somebody tell me what is D very quickly, because I'm not writing the whole derivation, because we know all these lengths. BD we know, DC we know, DH we know, AH we know, everything we know. Therefore, using section formula, we can do that. So, can somebody tell me what is D? नहीं, करूया derivation पूर्ण? No problem. How much is BD upon DC? If you want to involve trigonometry, BD.
Sure, I can tell the coordinates of D.
Yes, that is what I was waiting for.
It is x2 tan B plus x3 tan C by tan B tan C, tan B plus tan C. Same for the y-axis,
Yes.
y coordinates.
Same for y, that is okay. But quickly, if BD upon DC, if I wish to write, then what will it be? BD is C cos B upon B cos C. How do we get this tan B and tan C? That is what I'm trying to figure out. Now, if I replace C by 2R sine C cos B upon 2R sine B cos C, that is 2 cancel, RR cancel. This is tan B upon, sorry, tan C upon tan B. So BD upon DC is tan C upon tan B. Therefore, x3 into tan C plus x2 into tan B upon tan B. So do you understand now why D is like this? Okay. Now, how much is AH upon HD? This is important. This is what will recall your trigonometry, unless you remember those lengths, and that is why we have found out at that time. That is the whole purpose of finding out those lengths. So AH is 2R cos A.
2R sine A.
AH is 2R
cos A.
Sine A.
cos A.
Oh, sorry, cos A.
And how much is HD?
2R cos B
2R
cos
plus
C.
B cos C.
2R.
Cos B cos C.
Okay, now can we get them in Can we get them in tans? Can we convert this? Can we convert this cos A upon cos B cos C in tan? That is the question. What is the trigonometric simplification so that you get into tan business? Because we are interested in tan. Okay, this is altogether a different trigonometry problem. Okay, what
Sir,
yes.
Sir, the ratio will be tan B tan C minus 1.
Tan B tan C minus
1.
Yeah, I mean, whatever. I mean, what we need now is, because we have D looking like this, and A is x1, eventually the formula is going to be x1 tan A plus x2 tan B plus x3 tan C upon tan A plus tan B plus tan C, right? So AH upon HD I have written, which I should have, okay, anyway, AH upon HD. So this fellow, so let us say M upon N. So M into this coordinate plus N into X1. Okay, whole divided by M plus N. Should look like this. That is one way of looking at what is M upon N in terms of tan, and second way of looking at M upon N as tan is using trigonometry. How will you get tan A, tan B and tan C in this place? Maybe this will help. Sine A is equal to sine B plus C, because A plus B plus C is 180, and cos A tan A. Cos A tan A is sine A, which is equal to
Sir, it's better to put A as 180 minus B minus C.
Yes, sir.
what should we do?
Put in cos A 180 minus B minus C,
Okay.
which is 90 minus B plus 90 minus C, and then we use cos A plus B. And then we get cos B 90 minus B. Yeah, so cos 90 minus B into cos 90 minus C minus sine 90 minus C into sine 90 minus B. And then we just make it cos B cos C plus minus sine B sine C. So we get tan A tan B minus 1.
Okay. I mean, every individual can do it in different way. Every individual.
This is a much easier way to do all this. We
Everybody
can just consider the areas of HBC, like the ratio of HBC upon ABC.
HBC upon ABC. HBC upon ABC.
Area, yeah. That would be
HD
the
upon HD upon
coefficient of
AD.
A.
HD upon AD.
Yes, sir. So that would be the weightage of A for like the particular point. In general, for any point P, we can do that. Then, yeah.
Okay. Let me cross check, because if I know this, that it is going to be tan B plus tan C upon tan A, which is cos A upon cos B cos C. Let us see if we get it as AH upon HD. That is what I was actually doing here, but let me do it now again. Cos A cross multiplying. I assume that this is true. and verifying cos A tan A, is that really equal to cos B cos C into tan B plus tan C? Very good. So this is sin A. Okay. This is cos B cos C into sin B upon cos B plus sin C upon cos C, right? Which is, if I take LCM of this will get cancelled, and what will be in the numerator? Sin B cos C plus cos B sin C, which is sin B plus C. Is this true? Sin A is equal to sin B plus C? Yes, it is true. Therefore, cos A upon cos B plus cos C is equal to tan B plus C, tan B plus tan C upon tan A, and therefore our orthocenter is done. Good. Weightage is tan A, tan B, tan C. Now, final one is circumcenter. कोणाला लिहून घ्यायचं असलं तर आपलं थोडंसं ठेवतो मी बरोबर. Okay. Circumcenter, what will be the diagram that we can make? A, B, C, O. And now असं काहीतरी करायला लागेल. That is why I was asking for a better method. But anyway, let us see. So this is the now.
So
Yes.
so we can use that OG upon GH is 1:2.
Yes, that is a long method of doing it, correct? We can do it that way. I want a simplistic method of finding out O. And weightage is sine to A, sine to B, and sine to C. हा नीरव, सांग मला काय करायचं?
सर म्हणजे आपण म्हणजे इनसेंटरला कसं म्हणजे धरू शकतो आपण एरिया ऑफ म्हणजे ओमेगा 1 W1 इज इक्वल्स टू एरिया ऑफ IBC अपॉन ABC म्हणजे एरियल डेफिनेशन देऊ शकतो आपण त्याला. आणि म्हणजे तसं ABC अपॉन IBC अपॉन ABC A अपॉन A प्लस B प्लस C येतं. तसंच इकडे आपण BOC अपॉन एरिया ऑफ BOC अपॉन एरिया BAC घेऊ शकतो. आणि एरिया ऑफ BOC इज इक्वल्स टू BO इंटू OC इंटू BO इंटू OC इंटू 2R साइन BOC. आणि मग एरियल डेफिनेशन्सनी तसं होईल मग.
Let me pause and think. What he was saying is exactly similar. How much is this angle? 2A. How much is this angle? 2B. How much is this angle? 2C. All आता माझ्या डायग्राम मध्ये ते सगळे सेम नाही आहेत, पण दिस इज कॅपिटल R, दिस इज कॅपिटल R, दिस इज कॅपिटल R. बरोबर आहे? Therefore, BD upon DC is equal to area OAB upon area OAC, arrow. And area OAB is half R into sine to C. And area OAC is equal to half into R into sine to B. Therefore, BD upon DC is sine to C upon sine to B. Therefore, coordinate of D is equal to x3 sine to C plus x2 sine to B upon sine to B plus sine to C. That is xd. Okay? And now how will you go about DO upon OA. असं होणार आहे का आपलं as you got this x3 sorry xd as weightage sine to c, therefore the final point must be symmetric with respect to all the three vertices, and therefore sine a sine to a, sine to b, sine to c are the weightages. Or can you really apply section formula one more time? Think about it. Start thinking, we get an idea. Now, if I really want to write down OD upon OA, OA is R. So OD is this area. Yeah. Also, this area upon this area. And theorem on equal ratios, if we add numerator and denominator, we get ODS to OA as ODS to OA as area of OBC upon area of OAB plus area of OAC using theorem on equal ratios. Okay, area of OBC is now the same business here. Half R square will get cancelled, and therefore it will be sine 2A upon sine 2B plus sine 2C. I think it is clear now and very easy, and therefore the weightage for circumcenter is sine 2A, sine 2B, sine 2C. Circle. Ellipse आला पण ठीक आहे, circle. So in circle, what are the things that we are supposed to do? One, we know definition. It's a locus of point equidistant from a fixed point in a given plane. Second thing that we know is center radius form. X minus h bracket square plus y minus k bracket square is equal to r square, where h and k are centers, coordinates of centers, and r is the radius. 3. General degree to equation into variable which represents circle is ax square plus by square plus 2gx plus 2fy plus c is equal to 0, where a is equal to b, and it is not equal to 0, otherwise it will become straight line. Okay, 4. Okay, in this case, if it is general equation looking like this, which eventually we can convert it into x square plus y square plus 2gx plus 2fy plus c is equal to 0 form, then we get center as minus g comma minus f, and radius is equal to radical g square plus f square minus, we know this. 4th, dimetric form, x1 y1 and x2 y2 are extremities of diameter. then the equation of circle is x minus x1 into x minus x2, y minus y1 into y minus y2. Here, slope is m1, m2. Again, we can solve this using locus method. Any point on the locus m1, m2 is minus 1. Then fifth. Oh, this is good. This is very good. Determinant form of equation of circle passing through A1, x1, A2, x2, y2, A3, x3, y3 is. Can you guess what determinant we should write so that we get equation of circle passing through these 3 points? Now, okay, I will tell you what about that determinant later. But can you guess, because we have learned how to expand the determinant in last lecture, and maybe you know how to find out the equation of circle passing through 3 points. So you know it is going to be a long process, perpendicular bisectors, etc., etc. And finally the equation of circle also will look very long because it must have all these 6 people sitting there along with x and y. So it is going to be a long expression. So that expression can be put in determinant form, which looks very nice. Can you try and put it? अरे आता नको, कारण बाकीच्यांना थोडंसं डिटॅच वाटेल, कारण आपल्याला डिटर्मिनंटच्या प्रॉपर्टीज माहिती नाही. So the determinant will look like this: x square plus y square, x, y, 1, x1 square plus y1 square, x1, y1, 1, x2 square plus y2 square, x2, y2, 1, x3 square plus y3 square, x3, y3, 1. So this is 4 by 4 determinant, which is supposed to be equal to 0. This is the equation of circle. Now, why? Why is that equation of circle? We learned how to expand determinant yesterday. Suppose we expand it using first column. Then suppose this first entry, x square plus y square, and these are constants, x1, y1, x2, y2, x3, y3. They are all constants, and x and y are real variables, here and here, here and here. Okay, so this is 3 by 3 determinant, which is to be multiplied by x square plus y square, and therefore constant times x square plus same constant times y square. So coefficient of x square and y square is same. First condition for circle is satisfied. Understood? Then maybe, okay, we expand this using this row. Then second term will be x multiplied by minus times x multiplied by this determinant. Again, it is a constant, so constant times x plus y into which determinant? Sorry, y ही लाइन अवॉइड करायची आहे, इकडून y into this determinant, again constant times y, plus, so there is no xy term, that is the only condition. Constant times x square plus same constant times y square plus some constant times x plus some other constant times y plus constant 1 multiplied by constant. These are the constant. So is equal to 0 is bound to be a circle because coefficient of x square is same as that of y square and there is no xy term. Now, why will this circle pass through these 3 points? Because there is a property of determinant. If two lines or if two rows are same, then the value of determinant is always 0. So if we substitute x1, y1 in the first row, it looks like second row, and therefore x1, y1 will satisfy this determinant is equal to 0. If we put x2, y2 in the first row, it will be same as second row. Therefore, x2, y2 will satisfy this determinant is equal to 0. And x3 also, a3 also will satisfy determinant equal to 0. Therefore, now if we write it in expanded form, it will be a long expression. But by looking at this determinant, its expansion and characteristics for the general degree to equation to be a circle, coefficient of x square, y square should be same and there should not be xy term is getting satisfied here. Therefore, whoever has fabricated this determinant is great. I mean, but it gives us the circle passing through these 3 points. समझ ले? Parametric form of equation of circle. First of all, let us see how do you find out circle if the center is at origin. Okay, draw a ray. Let this point P x comma y be on the circle. The ray is making angle theta and the radius is r. So x is equal to r cos theta, y is equal to r sin theta. That is the parametric equation if origin is at, if center is at origin. So what will be the equation, parametric equation if the center is somewhere else? माझं सर्कल नीट का येत नाहीये. Center is at h comma k. Then what will be the formula? Origin is somewhere else. X is equal to h plus r cos theta, y is equal to k plus r sin. This is parametric equation of circle with center at h comma k and radius r. Next, seven. Okay. Find equation of tangent at on the circle tangent at x1 y1 which is on the circle x square plus y square dx y plus c is equal to 0. So this is a good job for you. Find the equation of tangent at x1 comma y1. That point is on the circle. The equation of circle is x square plus y square plus 2gx plus 2fy plus c is equal to 0. We would like to have this equation looking like this: x(x1) plus y(y1) plus g into x plus x1 plus f into y plus y1 plus c is equal to 0. This is the equation of tangent at x1, y1 to the given circle. And we are actually supposed to find out by a couple of methods. And I am sure you must have found out it by using special property of circle, that the tangent is perpendicular to radius segment at that point, which is good. That is why circle is good. It has many symmetric properties. But then that is a special property of circle, might not be available for any other conic. Parabola will not have that property. Circle, hyperbola, ellipse, hyperbola will not have those properties. Therefore, maybe we will have to have another method by which. अरे तुम्हाला डिफरेंशिएट करायला शिकवलं का रे विश्वेश सरांनी? हा नाही, डेरिव्हेटिव्ह काढायला नाही शिकवलं अजून. बरं, ठीक. ओके, so let us do it by basic method. What is basic method? We have a circle. We have a circle. अरे सर्कल कन्वर्ट का होत नाही. We have a circle, and we have a point. So tangent is a line which is having only one intercept with the circle. But if I draw secant, then it will have another intersect x2, y2. Correct? With respect to this circle, there will be, let us draw secant passing through x1, y1, and it will intersect circle at some other point x2, y2. Find equation of secant. काढा बघूया, दाखवा मला. Find equation of secant. Already, why am I asking this question? We already know equation of line passing through 2 points, but that is not the way we are supposed to answer now, because both these points are on the same circle. So we have to have this circle in place. Otherwise, the equation will be y minus y1 upon x minus x1 is equal to y2 minus y1 upon x2 minus x1. But then this is not expected. This is always this is going to be true passing through x1, y1, x2, y2. But in this case, these 2 points are on circle. Therefore, we have to bring this. I mean, both of them satisfy. This fellow is important information given to us. Therefore, even if this is universally true correct answer, it is not correct at this stage, because this is a straight line. Why should we call that straight line as secant? We will call it secant provided x1, y1 and x2, y2 satisfy equation of circle. Therefore, may be wrong at this stage. Okay, so what should we do? We should first say that x1, y1 satisfy the circle. Therefore, x1 square plus y1 square plus 2gx1 plus 2fy1 plus c is equal to 0, equation number 1. Similarly, x2 also satisfies x2 y2 plus c is equal to 0. This is equation number 2, correct? And then what we should do is we should subtract. Then we will get x1 minus x2 times x1 plus x2, that is x1 square minus x2 square, plus y1 minus y2 times y1 plus y2, correct? Plus 2g times x1 minus x2 plus 2f times y1 minus y2 is equal to 0. Okay, this is very good equation. Now all those x1, y1s and the circles are taken into consideration. Now let us collect all x1 minus x2 in one place. x1 plus x2 plus 2g, correct? And let us throw y1 minus y2 on the other side. Collect y1 plus y2 plus 2f. Is that right? Good. This implies y1 minus y2 upon x1 minus x2 is equal to. This goes in the denominator. I mean, we are assuming that denominator is good. x1 is not coincident with x2. Otherwise, we will get tangent itself. As it is secant, x1 is not equal to x2. Therefore, we can throw it in the denominator. And if we throw, what we will get is minus x1 plus x2 plus 2g upon y1 plus y2 plus 2f. Is that right? And this is what is the slope of the secant, m. What we are interested in is slope of the secant. And therefore, the equation of secant is y minus y1 is equal to minus x1 plus x2 plus 2g upon y1 plus y2 plus 2f. This is slope times x minus x1. Okay, this is secant. And we know limiting case of secant. Put a diagram. Diagram. What we will do now is we will take this point x2 along the circle like this. Therefore, secant will become like this, and suddenly the moment x2 coincides x1 and y2 coincides y1, we get tangent. So if x2 becomes x1, therefore this converts into tangent if x2 becomes x1, y2 becomes y1. So y minus y1 is equal to minus x2 becomes x1, that is 2x1 plus 2g upon 2y1 plus 2f into x minus x1, which is equal to y minus y1 into y1 plus f is equal to minus x1 plus g times x minus x1, which is equal to y1 plus yf minus y1 square minus y1f बरोबर आहे is equal to minus x1 plus x1 square minus gx plus gx1. बघा आता नीट चाललंय काय ते बघा नीट. Because everything is multiplied. Now everything is taken to LHS. If I take everything to LHS, I get xx1 plus yy1 plus gx plus g plus x1 x into sorry plus g into x plus x1 plus f into हे बरोबर लिहिलंय मी इथे सगळं मायनस x1 प्लस x1 स्क्वेअर
सर g into x minus x1.
इथे मायनस पाहिजे का घाई कशाला करतोय एक मिनिट हा समजा मायनस मी बाहेरच ठेवला आता तर व्हॉट विल आय गेट x1 प्लस सॉरी x1 माइनस x1 स्क्वेअर प्लस gx मायनस gx1 बरोबर. आता अपोजिट साइन सगळीकडे दिली तर अपोजिट बरोबर चाललंय. ओके त्यामुळे बरोबर चाललंय जे चाललंय ते वाईट चाललेलं नाही मग जसंच्या तसं घ्यायचं. पण मग इथे काय झालं y1 yf मायनस y1 स्क्वेअर मायनस बरोबर आहे की ओके जी इथे या दोघांची साइन सेम आली इथे या दोघांची साइन हा सॉरी बरोबर चाललंय नथिंग रॉंग. ओके x1 इकडून इकडे आला y1 तसाच ठेवला. मग मी समजा x कॉमन काढला तर आतमध्ये काय येणार आहे नाही x नाही कॉमन काढायचं आपल्याला g कॉमन काढायचं आहे. g कॉमन काढला तर आतमध्ये काय येणार आहे g कॉमन काढला तर आतमध्ये येणार x मायनस x1 बरोबर प्लस f इंटू y मायनस y1. त्यामुळे 1 2 3 4 5 6 आणि 2 टर्म्स राहिल्या विच इज मायनस x1 स्क्वेअर मायनस y1 स्क्वेअर इज इक्वल टू 0. ठीक आहे आता बरोबर चाललंय इज इक्वल x1 प्लस y1 प्लस g इंटू x प्लस x1 मी लिहिलं तर मायनस होतं त्यामुळे प्लस लिहिलं देन आय हॅव टू सबट्रॅक्ट मायनस 2gx1 प्लस f इंटू y प्लस y1 जर मी लिहिलं तर आय हॅव टू सबट्रॅक्ट 2f y1 प्लस और मायनस x1 स्क्वेअर मायनस y1 स्क्वेअर इज इक्वल टू 0. करेक्ट. तर आता एवढ्या सगळ्या टर्म्स ऑल दीज टर्म्स ऍडेड टुगेदर दिस along with these 3 is plus c and therefore you get x1 plus y1 plus 2g plus g into x plus x1 plus f into y plus y1 plus c is equal to 0. That is what is the equation which we were looking for of tangent. That is what is denoted by t is equal to 0. This is t is equal to 0. T is equal to 0. Okay, finally I could complete the algebra. Find the equation of tangent at, okay, let me write down the equation of circle first. X square plus y square plus 2gx minus 4fy, and suppose I take point 2, 1. I want this point on this circle. अरे सॉरी g वगैरह चालणार नाही काय का आपल्याला. टू एक्स माइनस 4y प्लस और माइनस 4 अधिक 1 5 अधिक 4 9 वजा 4 म्हणजे 5 minus 5 is equal to 0. So very easy. Find the equation of tangent, or write the equation of tangent at this point to this circle. Okay. So x1 is 2, y1 is 1, therefore you can use this formula to find out the equation of tangent, and it reduces to 3x minus y minus 5 is equal to 0. Now last problem, x square plus y square plus 7x plus 3y minus 6 is equal to 0, and the point is 1 comma minus 1. Write the equation of tangent. Answer 9x plus y का minus y
One.
Plus 1.
plus y is equal to 8 is the answer for this. Okay.